Okay, now, since we know what a limiting reagent is, we understand the meaning of theoretical yield, we know the meaning of actual yield, we're going to see how we can solve limiting reagent problems. And after this particular class, we're going to understand everything about limiting reagents. Let's solve problem number 1. The question says, acetic acid is prepared according to the equation. This is the equation on the board. I have CH3, CHO plus O2 to give HC2, H3, O2. Okay. Acetic acid is prepared according to the equation on the board. If 20 grams of acetaldehyde and 10 grams of oxygen were mixed, question A says, what is the limiting reagent? B, what is the excess reagent? C, how many grams of acetic acid can be produced from this reaction? Then the D part, what is the theoretical yield of acetic acid in the reaction? And the E part, what mass of excess reagent was consumed in the reaction? And the F, what mass of excess reagent remains after the reaction is complete? And the G, given that the experimental yield of acetic acid is 19.1 grams, calculate the percentage yield of acetic acid. Let's start from the very first part of this question. First things first, every chemical equation must be balanced. So first things first, let's balance the chemical equation. Now we balance by putting a 2 here and by putting a 2 here. The equation becomes balanced. We've done everything about balancing of chemical equations in my previous video. So if you're confused about balancing the equations, you can go back to my previous videos and you can check it out. So now since the equation is balanced, we are given the following masses. We are given, let me see, we're given 20 grams of acetaldehyde and we're given 10 grams of oxygen. So option A, question A says, what is the limiting reagent? So how do you find the limiting reagent? Now I gave you two short methods. Now let's try the very first method. So to find the limiting reagent, first thing you have to do is you can decide to divide the amount given to you in grams by the molecular weights. By the molecular what? Weights. So you divide by the molecular weight, you compare the two answers you're going to obtain. So after comparing the two answers you're going to obtain, any answer that is smaller, the reagent that gave you that small amount is the limiting what? Reagent. That's a very short method you can use to find the limiting reagent. Now let's check this out. So I have 20 grams of that. I want to divide by the molecular weight of this molecule here. And the molecular weight is gotten by, carbon is 12. 12 plus 3 gives me 15. 15 plus 12 gives me 27. 27 plus 1 gives me 28. And 28 plus 16 gives me 44. But there are two moles here, right? So 2 times 44 gives me what? 88. So I'm going to say 20 over 88. Now I'm going to get an answer here. I'll do same on this other side. So on this other side, I have 10 grams here. I'm dividing by 16 times 2, which is equal to what? 32. So 32. I'm going to get an answer here. So what are my answers? So what is the answer to this? Can I get the answer from the audience? Point what? 0.23. What about the answer here? 0.31. Compare the two answers. Which of these answers is smaller? Which one? 0.23, right? So meaning that my limiting reagent is what? Acetaldehyde. All right. That has been established. So therefore, my limiting reagent is acetaldehyde, limiting reagent, and my excess reagent is what? Oxygen. I'm done. So we answer the A and the B part of the question that says what is the limiting reagent and what is excess what? Reagent. Let's go to the C part of the question now. Or can we use a different method to get this? Can we try a different method? Let's try a different approach. So instead of using a short method, can we use another approach to get the limiting reagent and the excess? Let's try. Let's use stoichiometry. So let's answer question A and B again using another method now. So let's say, please look up guys. So guys, now I was given 20 grams of acetaldehyde combining with what? 10 grams of what? Oxygen. I want to know the limiting reagent. What will I do? I will say from the balanced equation, I can see clearly here that the molecular weight here is what? Is what? Is 88. Is what? 88. So I have that 88 grams of acetaldehyde will always react with what? 16 times 2 is what? 32. So it's going to react with 32 grams of what? Oxygen gas from the balanced what? Equation. Now the question now is 20 grams of acetaldehyde will react with what amount of oxygen? Let's check. It's going to react to 20 times 32 divided by what? 88. So I have 20 times 32 all over 88 grams of oxygen. And what amount is this? Please, can we have the answer? Let me try my 7 point what? 7.27 grams of oxygen. Wow, can you see that? So that simply tells you that 20 grams of acetaldehyde will only react to what? 7.27 grams of what? Oxygen. Now the question now is, what amount of oxygen was given to you in the question? Is what? 10. And out of 10, is going to react to only what? 7.27. Meaning that oxygen is in what? Is in what? Excess. Is in what? Excess. So I'm going to have an excess of what? Oxygen. Because 20 grams of acetaldehyde is only going to react with what? 7.27 grams, which is not even up to the amount that was what? Given. So what does that imply? That implies that my excess reagent is what? Is what? Oxygen. While my limiting reagent is what? Acetaldehyde. So that's another method you can use to figure out the limiting and the what? Excess. So you can choose between the two methods, the one that you like. You can use it to find the limiting and excess. So let's now go over to question number C. So I have my limiting reagent, I have my what? Excess what? Reagent. Let's go to the C part of the question now. Now the C part of the question says, how many grams of acetic acid can be produced in the reaction? Now remember, acetic acid is my product, right? And the limiting reagent determines the amount of product that can be obtained in a chemical what? Reaction. So what we did first was the right thing. The first thing I'm supposed to do is to find out which of the reagents is the limiting what? Reagent. So now that we know that the limiting reagent is what? Acetaldehyde. So it is clear and it is right for us to say that acetaldehyde will tell us the amount of acetic acid to be obtained in this what? Reaction. So I'm going to do a very simple stoichiometry between the limiting reagent and the what? And the what? Product and acetic acid. Can we try it out? All right. From the balanced equation, what do we have? From the balanced equation, I have that 88 grams of acetaldehyde will produce what amount of acetic acid? Let's check it out. What is the molecular weight? Let's check it out. So I have that hydrogen is 1, right? Okay, 1 plus 12 times 2 is 24, right? So 1 plus 24 is what? 1 plus 24 is 25. 25 plus 3 is what? 28. 28 plus 32 give us what? 60. 60 times 2 will give us what? 120. So that will give us 120 grams of what? Acetaldehyde. Sorry, of acetic acid. Sorry. HC2H3O2. All right. So from the balanced equation, 88 grams of this will give us what? 120 grams of what? That. So now the big question now is, therefore, 20 grams of the limiting reagent CH3CHO will give us what amount of what? Acetic what? Acid. So let's check it out. It's going to give us 20 times what? 120 all over what? 88. And what's the mass here? Now give us check it out. What's the answer then? Now give us 27.27 grams of what? Acetic what? Acid. So now this is the amount of acetic acid that can be obtained from this what? Reaction. Remember, The amount of product that can be obtained from a particular reaction is dependent on the limiting what? Reagent. So the limiting reagent, which is acetaldehyde, gave us 27.27 grams of what? Acetic what? Acid. Now pay attention to this. This is the maximum amount of product that can be obtained from this what? Reaction. Are we together? All right, now check this out. Also note that this maximum amount of product that can be obtained from this particular reaction is also called the theoretical yield. What do I call the theoretical what? Yield. All right. So we've answered the question C. What's question C? It's saying how many grams of acetic acid can be produced in the reaction? The answer is what? 27.27 grams. Now the D part now says, what is the theoretical yield of acetic acid in the reaction? The answer remains 27.27 grams. So those questions are the same. So C and D are what? The same. All right. Let's now go to the E part of the question that says, what mass of excess reagent was consumed in the reaction? Now pay attention, pay attention, pay attention. Now this particular question, we've solved it before in this class. I solved it 2 minutes ago, but I want us to solve it again. So we're looking for the amount of excess that was consumed in the what? Reaction. Now, if you want to know the amount of excess that was consumed in a particular reaction, what are you going to do? Now, pay attention. You're going to convert grams of what? Limiting reagent. Are we together? To what? To grams of what? Excess what? Reagent. You're going to convert grams of limiting reagent to grams of what? Excess reagent. Now, how are you going to do this? Just a simple stoichiometry between the limiting reagent and the what? Excess. Am I communicating? All right, so limiting and what? Excess. So if you say, okay, from this balanced equation now, I can see clearly here that the molecular weight here is 88, right? I can see that 88 grams of the limiting reagent CH3CHO will always react with what? 32 grams of what? The excess reagent oxygen. Are we together? So now the question now is 20 grams of what? Acetaldehyde, that's the limiting reagent, will react with what quantity? You check it out. That'll give us what? 20 times what? 32 over what? 88 grams O2. And that'll give us what? 7.27 grams of what? O2. Now check this out. This answer we just obtained now is the amount of what? Oxygen. Or you say the amount of excess that is going to be consumed in this what? Reaction. So we can just simply say that in this particular reaction, 7.27 grams of oxygen was what? Used. Was what? Used. So we've answered the E part of the question that says, what mass of excess reagent was consumed in the what? Reaction. Let's now go to the F. The F part says, what mass of excess reagent remains after the reaction is complete? At this point, we don't really have much to do because we now know the amount of excess that was what? Consumed. So if we know the amount of excess that was consumed, we can simply figure out the amount of excess that did not what? Participate in the reaction. Am I communicating? Let's check this out. Can I clean this step? So we know that 7.27 grams of oxygen gas was what? Consumed in the reaction. So what amount of oxygen was not consumed? Remember, total amount was what? 10 grams. And out of 10 grams, how many grams was consumed? 7.27. So meaning that the rest was not what? Used. Let's check that out. So in simple terms, we can say that unreacted oxygen, which is the excess, is equal to 10.00 grams minus what? 7.2 what? 7 grams. Because 7.2 is the amount of what oxygen that was what? Consumed. And this is total what? Amount. So what amount did not react? What's the answer here? 2 point what? 2.73 what? Grams of oxygen remained what? Unreacted. That's beautiful. Are we together? All right. So we're done with the F part of the question. Let's now go to the G part. Now the G part is talking about you are given the experimental yield of acetic acid here, and you're told to calculate the percentage yield of what? Acetic acid. So how do you calculate the percentage yield of acetic acid? I can tell you, right? All right. So my percentage yield is equal to what? The actual over what? The theoretical yield times what? 100. You see that? So that is what? The percentage what? Yield. Now if you go through that problem, you notice that when we solve I think that was the D part of the question, we obtained the theoretical what? Yield. And we got it at what? What's the value? Check again. 27.27. Beautiful. And the question has given us the actual yield. Now, why will the question always give you the actual yield? Because the actual yield is also called the experimental what? Yield. That is the value of product obtained from the main reaction. From the what? The main reaction. Now, what the theoretical yield is the amount that you obtain from stoichiometry. So there are two different things. So we must give you the actual yield, while you must obtain what? The theoretical what? Yield. All right, let's do the calculation now. So I have that. Percentage is equal to, actually is given as 19.1 grams all over. What is my theoretical yield there? 27.27 grams. But what about what? 100. So what's my final answer here? Okay, that's 70 point what? 70.04%. Are you sure about that? All right. So this is my percentage what? Yield. Now this percentage yield is a very good yield, right? Meaning that a very good quantity of my acetic acid was actually what? Obtained. Am I communicating? All right. So we're going to solve the second part of we're going to solve the second question now that works just like this. You get? So let's solve the second problem now. Problem number 2. Now for problem number 2, it involves a limiting reagent problem just like this, but this time around we're going to be solving problems in moles, not in grams. What do you want? Grams. Let's solve problem number 2. Okay, now from the problem on the board, problem number 2. Problem number 2. Are you with me? All right. So we have this particular equation here for problem number 2. We have KO2 plus H2O, which gives us KOH plus O2. All right. That's the problem. So, and when this equation is balanced, what are the coefficients? Let's have it. What are the coefficients here? 4. What's the coefficient here? 2. What's the coefficient here? 4. And what's the coefficient here? All right. So that's the balanced equation. So if you have problems with balancing chemical equations, like I said before, you can refer back to my videos on balancing chemical equations. All right. So this question, we have 6 parts here. The first part says, given 0.25 moles of KO2, so we are given 0.25 moles of KO2, and we are given 0.15 moles of what? H2O. Now the question says, what is the limiting reagent? Then the B part says, what is the excess what? Reagent. Like we saw before, you can still apply the same principles right here. Now, remember what I told you. If you are giving limiting reagents, or let's say, sorry, if you are giving amounts or quantities in moles, are you there? Now, simply divide these amounts here by the stoichiometric coefficient in the balanced what? Equation. So after dividing by the coefficients, you compare the answers. Which one is smaller? Now, the one that gives you a smaller amount, that is the limiting what? Reagent. It's similar to the one I gave you before. Remember, it is given to you in grams. What do? You divide the grams by the what? The molecular weight alongside the coefficient. Are we there? So in this case now, I'm going to be dividing by what? The coefficient only, because I have my quantities in what? Moles. So I have 0.25 all over what? 4. That's my coefficient, right? So I have 0.15 all over what? 2. Now check this out. What's going to be the answer here? 0. What? 0.0 what? 625, right? What about this one here? 0.075. Now compare the two answers here. Which of them is smaller? Which of them is smaller? Is this, right? All right, so meaning that my limiting reagent is potassium superoxide, KO2. All right, so that's my limiting reagent. So we move on to the next step. So if potassium superoxide is my limiting reagent, my excess reagent is what? Water. Does that make sense? You can still try the second method, right? It will still work. Now, for the second method, we're going to do pure stoichiometry, right? So for the second method now, we are working in moles, don't forget. So from the balanced equation, I can say that 4 moles of KO2 will always react with what? 2 moles of what? Water. That's the balanced equation, right? So now, therefore, 0.25 mole of our KO2 will react with what amount? I'm going to cross multiply, right? So I have 0.25 multiplied by what? 2. Divided by what? 4. Moles of water. So what will be the answer here? Check. What's the answer here? 0.125 mole of what? Water. That makes a lot of sense to me. Now check this out. You can see from this analysis here that 0.25 mole of KO2 will only react with 0.125 mole of what? Water. That tells you that this particular reactant here, are you there? It's in excess. It's in what? Excess. Because the quantity originally given to us is what? 0.15. So out of 0.15, 0.25 moles of KO2 is only going to react to 0.125. Meaning that we still have some amount of water left unreacted. Am I communicating? So that tells you that from that analysis, the limiting reagent is what? KO2. And the excess reagent is what? Water. Does that make sense? So any of the methods you like, you can use and get your limiting reagents. Let's go to the next problem. So we've done A and B. Now the C part of the question says, what amount in moles of oxygen can be produced from this reaction? We are considering oxygen as our product, right? So we want to know what amount in moles of oxygen can be produced from this what? Reaction. Don't forget, the limiting reagent will determine the amount of product that can be produced in this what? Reaction. And at this point, we know that the limiting reagent is what? Is what? KO2. That's potassium superoxide. So we're going to do a very simple stoichiometry connecting potassium superoxide and what? Oxygen. And what? Oxygen. And from the balanced equation, we can see here that 4 moles of KO2 will produce 3 moles of what? 3 moles of what? Oxygen. Very simple. So therefore, 0.25 moles of KO2 will produce what amount of oxygen? Let's check it out. Times 3, right? Divided by what? 4. Does that make sense? Let me write this well. So what are we going to have here? That's equal to 0. What? 188 what? Mole of what? Oxygen. Now pay attention here. Pay attention here. Now, we just got the amount of what? Oxygen that can be produced from this what? Reaction. So this amount of oxygen that can be produced from this reaction is the maximum amount of oxygen that can be produced from this what? Reaction. And it is also called the theoretical yield of what? Oxygen. In what? In what? In moles. In what? Moles. Right. So can we move on to the next one? All right. Now let's now go to the next question that says, what is the theoretical yield of oxygen in moles? What is the answer? 0.188 mole. That's the answer. That's the theoretical what? Yield. Beautiful. Let's now go back to the next part of the question that says, what amount in moles of excess remained unreacted? Let's check it out. What amount in moles of excess, are we there? Remain what? Unreacted. Now let's check this out. We know our limiting reagent at this point, and we know our what? We know our what? Excess. Before you can figure out the amount in moles of excess that remained unreacted, you have to first of all find the amount in moles of excess that participated in the what? Reaction. In the what? Reaction. How do we do that? So we're going to do, like I said before, we're going to do a stoichiometry between the limiting reagent and the what? The excess reagent. Now we're going to do that in moles, right? So from the balanced equation, we have about 4 moles of KO2. We react with what? 2 moles of water. So 0.25 moles of KO2 will react with what amount of water? It's going to react to 0.25 times 2, all over what? 4. So what's the final answer here? So we have 0.125 mole of what? Water. Now pay attention here. So this is the what? The amount of water. Or you can say the amount of excess that participated in the what? In the what? Reaction. So this is the amount of water that will react. Are we there? Now don't forget. Pay attention. Don't forget. If you want to find the unreacted, what find the amount of water that did not what? React. Go back to the original. What amount of water was provided for us is what? 0.15, right? So 0.15 was already provided. And out of 0.15, 0.125 reacted. Are we there? So what amount did not react? So we're going to subtract this from this. Are we there? And what would that give you as the final answer? 0.15 and 0.125. What's the final answer there? That gives you what? 0.025 mole of what? Water. So this is the amount of what? Amount of what? Water that did not what? React. So that is the amount of excess that did not react. Beautiful. So what's the next part of the question now? It says, that's the F part. It says, if the experimental yield of, I can see this well. Okay, I can see it. If the experimental yield of oxygen was, I can't say this. Okay, if the experimental velocity is 0.11 mole, what is the percentage yield? Now, this time around, they're going to be calculating our percentage yield in what? In what? Moles. In what? Moles. And how do we do that? Experimental yield is given to us in moles, so we have, that is the actual yield, 0.11 mole. So what is the theoretical yield? Is what? 0.188 mole, as we calculated initially, right? So now the percentage yield here will be equal to what? Equal to the actual yield over what? Theoretical yield times what? 100. So that's same thing as saying 0.11 over what? 0.188 times 100. So what's the final answer here? Check it out, let's have the answer. What's the answer there? Please verify. I need the correct. Let me check from here. 0.11 divided by 0.188 times 100. Okay, so the final answer is 58.5. So I have 58.5%. So this is my percentage yield. Now, if you follow through the first two problems I solved today, you can solve every problem on limiting reagents. See you in my next class, we'll be talking about types of chemical reactions. Like, share, subscribe. See you in my next class.